Meta-atoms, the next Mars Rover, detecting diabetes, and industrial photonics. That's this week on Light Matters. Hello, I'm Laura Marshall, and this is Light Matters for August 6, 2014. A new metamaterial that is deformed by light while altering its polarization could become a tool for developing photonic circuits. A team from Australian National University's Research School of Physics and Engineering made this new finding while developing metamaterials. These were formed from a pattern of tiny metal shapes called meta-atoms, which were then used to achieve optical rotation. The researchers demonstrated that this effect is available in artificial electromagnetic systems and enabled by the advent of magnetoelastic metamaterials, which produce nonlinear effects including self-oscillation. The researchers used a pair of C-shaped meta-atoms, one suspended above the other, to achieve optical rotation. They said that when light shines on a pair of meta-atoms, the top one rotates, making the system asymmetric. Chiral symmetry breaking in the system's strong stationary response prompts nonlinear polarization change. Such materials could be a new tool for processing light, according to the researchers. The research is published in Nature Communications. Imaging and spectroscopy equipment will join an unmanned NASA rover on Mars in 2020, allowing scientists to explore the red planet in unprecedented detail. Arizona State University will provide the Mastcam-Z camera system with panoramic and stereoscopic imaging. Scientists hope to piece together the geological history of the rover's landing site. A supercam, now in development at Los Alamos National Laboratory in New Mexico, will provide imaging, chemical composition, and mineralogy analysis. NASA's Jet Propulsion Laboratory in California is set to provide a UV spectrometer called SHERLOC, or Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. This device will examine fine-scale mineralogy and organic compounds. Among other devices to be included in the mission are an X-ray lithochemistry fluorescence spectrometer and a ground-penetrating radar imager to explore the geological structure of the subsurface. An experiment will also be conducted to investigate how to produce oxygen from Martian carbon dioxide. The total development cost of these technologies is estimated at $130 million. Earlier detection of a diabetes complication is now possible with a new optical technology. The new technology, developed at National Taiwan University Hospital and National Chiao Tung University, is a compact device that attaches to eyeglasses and features IR LEDs and a CCD camera. During physicians' appointments, it monitors the pupils to detect the earliest signs of diabetic autonomic neuropathy. This common complication affects the nerves that control vital organs, including the heart and gastrointestinal system. The device includes colored lights that stimulate the pupil, while a beam splitter attached to the device filters the visible light that is reflected from the eye. While clinical trials with the new device are ongoing, the researchers plan to scale down the device size and expand its capabilities to observe two pupils simultaneously. The research is published in Applied Optics. Materials processing is a dominant theme of the new issue of Industrial Photonics magazine. The cover story by contributing editor Hank Hogan explores how lasers are being used for micromachining, cutting, and welding. Web managing editor James Lowe recently spoke with Hank about the piece.
Hi Hank, welcome to Light Matters.
Hi.
Can you start by telling me the types of materials processing that lasers are good for?
They're good for cutting and welding materials. They're good for drilling holes in materials. They're also good for sometimes, depending upon the laser, ablating materials so that you can very finely get rid of protective coatings and overlays and things like that.
Now, of course, the same kind of laser isn't going to work for all those different applications. What types of different lasers are used and what separates one from another?
Well, there's all sorts of lasers that are used, ranging from diode lasers to disc lasers to fiber lasers. The big dividing line is whether or not you need fine control, in which case you want to use an ultra short pulse width laser because that gives you fine control. The drawback is that sort of fine control means you cannot do a lot of material processing. It's very slow. So in the case of if you're trying to join two pieces of metal together, or you're trying to somehow shape a surface, or you're trying to cut a big sheet of metal, then what you're looking for there is a laser that's got a lot of power, and in that case You probably go with a fiber laser, although there also are disc lasers that are, and even the old CO2 lasers are still used for that. I think the most interesting thing that didn't, or made it in only marginally, is this whole thing about 3D printing. Because in terms of material processing, 3D printing promises to really change the way material processing is done by allowing you to do stuff like you're a ship at sea and you need a spare part. Well, you don't have to stock the spare part, you can just print it. Since a lot of 3D printing involves lasers, then that's an area that down the road would probably it could potentially be a really large growth area in laser material processing. Certain things like aerospace, aviation, the plane that's flying, right? The biggest cost they have is fuel. So therefore, every pound you can take out of the plane, that's worth a lot. I've seen prototypes where they've taken like 80% of the weight out of something just by going to additive manufacturing and 3D printing. The other place where it is probably going to show up, it's already showing up in aviation. The next place it's probably going to show up is the military. And the thing about the military is they have these long logistical supply lines. They operate around the world. And if they can make parts on site, then they can get rid of that supply line. And that's worth quite a bit to them. I think for industrial manufacturing, the price has to come down and or the speed has to go up, which is really sort of the same thing. And given that, then you can start to see it. But until you get to that point, what happens is people that are willing, that get a large payback, which is the aerospace industry, or people that have a great need, which is the military, are the people that are going to pursue this initially. And then hopefully as prices come down, you can start to see it showing up in more standard industrial applications.
You can read Hank's article and others about materials processing at indphotonics.com. That's it for this edition of Light Matters. Email us your questions or comments at lightmatters@photonics.com, and don't forget to follow us on Facebook and Twitter for news updates every day. Thanks for joining us. We'll see you next time.